Hi guys, here's the last of our volume videos. This one is about finding the volume of a solid. So there's two things we can find the volume of, and one is a regularly shaped object like this block. There are formulas that we can use mathematically to determine the volume of an object that's regularly shaped. A cylinder, a sphere, a square, a rectangle. Okay, we can use the formula to do that. So that's the first way we're going to do it. And the formula for finding the volume of a block, a rectangle, is to find the length times the width times the height. So we have to measure those things and then use the formula. And here's the formula. It's length times width times height, or we usually write it as L times W times H. And that gives us the volume. So we have to be good with our measurement in order to do a good job with this. We have to use the formula correctly. But then the thing that often messes up with students is that they don't do the units right. So we're going to pay attention to all those things. So I'm going to use my tape measure. I'm going to use the centimeter side. And I'm going to be super careful because when you're measuring volume and you're multiplying these together, tiny little mistakes make a big mistake at the end. Whenever you multiply and divide, that happens. All right, so notice that my tape measure has the tiny little marks on one side and no tiny little marks on the other side. So I'm going to try and make sure that my tiny little marks are lined up with the edge of my block. So I'm going to work on it this way. And I'm going to line that up with the edge. Okay, I'm going to make sure that the end of my tape measure is lined right up with the edge. I'm going to be super careful that it happens that way. I'm going to look down as I'm measuring it and not off from the side. I'm going to try and see exactly where my block ends, and I'm going to say 7.1 centimeters. So I'm going to write that on my paper. That's the length. You know, it doesn't really matter that one is length and one is width and one is height. Just make sure you're measuring 3 different sides. So for my length, I said 7.1 centimeters. So here I'm writing it down because now I need to measure the next one, which is the width. Okay, so I decided the width is going to be this way. So again, I'm going to line it up so that my little tiny marks are lined up with the edge of my block. Line up the end of my tape measure with the edge of the block and look down as I'm measuring, and I'm going to say it's 4.55. I had to estimate that last digit. So 4.55 centimeters. I'm going to change my multiply sign to an X because I want you to make sure you know that's what it means. Even though the dot does mean multiply, I just changed all my dots to X's so you would know that that means multiply. So far I got 7.1 centimeters times 4.55 centimeters, and now I have to measure the height, which is this direction. Same old same. I'm going to grab this and line it up nice and perfectly on the edge. And you know what? This side had a little chunk taken out of it, so I'm not going to measure that side. I'm going to measure a side where it's very straight. So lining it up very carefully, looking down, and I'm going to say 6.8 centimeters. All right, so here it is. I'm going to multiply those together using my calculator. So 7.1 times 4.55 times 6.8 equals 219.67. 219.67. Big number. Like for a tiny little block like this. Who knew it had 219.67 centimeters inside this block? But it does. We're not done though, because we have to have units. Here's where students get mixed up. See, in this equation, we multiplied 7.1 times 4.55 times 6.8. We multiplied all the numbers together and got 219.67. We also have to multiply the units together. So what do you think centimeters times centimeters times centimeters is? Centimeters times centimeters times centimeters is centimeters cubed. And that looks like this. Centimeters cubed. Okay? Maybe you remember when you find area, length times width, that's always going to be centimeters squared because it's only the length times the width, two different dimensions, so that's only two numbers you're multiplying together. 2 centimeters you're multiplying together. Here you're multiplying 3. So it's centimeters cubed. All right, I'm going to pause the video now, and I'm going to go grab my supplies so I can show you what an irregular object is like when we find its volume. Okay, so where we used a formula to find the volume of a regularly shaped object, when we have an irregularly shaped object like maybe a rock or some marbles would be like that, they're hard to measure using the tools we have. Something like this would be really hard to measure as well, because we could measure its length and we could measure how big this thing is, but we'd have to account for all of the sides that are regularly shaped here. We'd have to account for all of the threads in the bolt itself, and there's a much easier way to do this. So to find how much space this takes up, we're going to use a method called water displacement. You can use that for anything that is okay to put in water. So here's how you do it. All right, so I'm going to put some water in my graduated cylinder. Let me turn this a little bit so you can see what I'm working on. So I'm going to put some water in here. And it really does not matter how much water I put in there, as long as it's more than the top of this thing that I'm going to put in it. So I can put in a lot, I can put in a little, really doesn't matter. It just needs to be more than what I had in there, or more than the height of this thing. Okay, so I got some water in there, and I'm going to read it now. And remember, when I read the volume of a graduated cylinder, I need to get down so that I'm looking at it from eye level, and I'm looking at the meniscus and everything. Well, I did a pretty good job. I got it at an easy to calculate number. It's not like in between two lines. If it was, you'd have to account for that as you read it. But it's right at 35 milliliters. That's how much water is in there right now. So I'm going to slide this into the water. And what's going to happen to the water when I put this in there? The water's going to rise, right? Just like when you get in the bathtub, the water rises. Okay, so, and I'm not just going to drop it in, because if I drop it in, then water's going to splash out. And if I lose some of the water, that's going to mess up my measurement. Besides making a mess, it's going to mess up my measurement. So to put this in, I'm going to tip this on its side, and I'm just going to sort of slide this in so it doesn't make a big splash and I don't lose any of the water. So remember, what was my starting volume? 35 milliliters. Let me write that down. Okay, so my starting volume was 35 milliliters, and now I have my end volume, which if I get down and look at it, remember I need to get to eye level again. This time it's at 41 milliliters. So you can do that. You can do some math in your head, or you can plug it into your calculator. So this was my starting volume, 35 milliliters, and after I put in the object, it was 41 milliliters. So if we can find the difference between these two numbers, we know the volume of that bolt, because the space it takes up is the space it's taking up in the water. So the amount that the water rises represents exactly the volume of that bolt. And so 41 minus 35 is how many milliliters? It's 6 milliliters. So the volume of my bolt is 6 milliliters. So that might seem weird because in the last slide, or the last example I gave you where I was finding the volume of this object, I was using the units of centimeters cubed. Okay, and now I'm using the units of milliliters, and when I measured volume of water, I used milliliters. Those two things are interchangeable. Centimeters cubed is the same thing as milliliters. We just tend to use milliliters when we're using liquids, and we use centimeters cubed when we're using solids. But they mean exactly the same thing. Okay? Good practice with that one, and I'll talk to you in class.